Good evening, students. Good evening, students. Good evening, Stefano, Kanishka. Good evening. I think more students has to join. We'll wait for some time. Okay. Good evening, students. Okay. So, Joel, good evening. Good evening, Joel. More student. George Vincent, good evening. Kavita Raj, good evening. Good evening. So, students from other platforms, good evening. Stefano, good evening. Okay. So we'll just move into the class. Okay, so last class we have finished till all the sums in NEET and NCRT regarding vectors. Okay, today we'll see about Ganesan. Good evening, welcome to the class. Joel Samraj, good evening, welcome to the class. Students, you can give a chat. Okay, so last class we have seen the questions regarding Kandeepan. Good evening, welcome to the class. Mithun, Karthik, Gunesegaran, good evening, welcome to the class. So last class we have seen till vectors. We have finished the questions with respect to NEET and also some NCRT questions. So we have completed vectors. Okay, Dhanalakshmi, good evening. Today we are going to see a topic called projectile motion. Okay, it is an important topic. Badma Krishnan, good evening. Mithun Karthik, good evening. So with respect to in terms of NEET, when you're attending NEET, okay, so in motion in a plane, this is for NEET students. Okay, so in motion in a plane, if three questions are being asked in NEET, okay, then they will ask like this, that is projectile motion, there will be a question. Okay, and in circular motion, uniform circular motion, there will be one question, and relative velocity, they will ask one question. So in NEET, if they're asking three questions in motion in a plane, Kannappa Rajendran, good evening, welcome to the class. So in NEET, if they're asking like in motion in a plane, three questions are being asked in NEET, means you will have like this: in projectile motion you'll have one question, in circular motion you have one question, and in relative velocity you'll get one question. This was the pattern in 2019 NEET. Okay, and in 2020 also, like more or less the same, but we had some, they had some similar questions has been asked in NEET 2020. Okay, so this I'm saying to make you understand the importance of this topic, the projectile motion. Okay, we'll solve some of the. Good evening, sir. I am Tushita Raj. Okay. Okay, Tushita Raj, welcome to the class. Okay, so you can attend the class. Okay, so see, so projectile motion is important when it comes to NEET, JEE, and also in your CBSE. You have some of the NCERT exemplar questions, which will be very useful if you study NCERT exemplar and some of your NCERT questions also. If we solve, you can solve these two very easily. Okay, so we'll see projectile motion. Okay, so what is a projectile motion? Just take down. Projectile motion is nothing but, is an example of a curvilinear motion. Curvilinear motion. Curvilinear motion. Okay, that is when object is moving in a curved path. When object is moving in a curved path. Okay, curvilinear motion. Okay, Kanishka. Okay, so when object is moving in a curved path. Okay, so projectile motion is an example of an curvilinear motion. Is nothing but a curvilinear motion when object is moving in a, so in projectile motion the object will be moving in a curvilinear motion. Okay, Jashwant Lakshmipati, welcome to the class and good evening. Okay, so students watching from YouTube also, you can also comment. Okay, and so that is called as projectile motion. Okay, so during projectile motion the object will be traveling in a curved path. Okay, so when an object is projected, okay, when object is projected, okay, with the initial velocity, just write down this. When an object is projected with initial velocity, okay, when an object is projected with the initial velocity, it makes an angle with the horizontal. Okay, it makes an angle with the horizontal. Okay, so when object is projected with the initial velocity, it makes an angle with the horizontal. I'll explain this. Okay, you just copied this down. Okay, students, you just copy this down. I'll explain this. Okay, so okay, when object is projected with an initial velocity, it makes an angle with the horizontal. Okay, so the motion of the particle, we can say the motion of the particle, when object is projected, okay, with the initial velocity, it makes an angle with the horizontal. Then the motion is said to be, I could only the topic, sir. George Vincent, you could only hear the audio and you can see the topic. Just refresh it, George. If you refresh it, it will be okay, I guess. Or you want me to write in larger fonts? If you want me to write in larger font, just give a comment. I'll do it. Okay. Or else just refresh now. Okay. So the motion is said to be neither vertical, okay, nor horizontal. So when an object is projected with initial velocity, okay, thank you, Kanishka. So hope everybody is clear with this, because is my audio and the screen, the video is clear? Okay, I think it is clear. If it is not clear, just let me know. Okay, so projectile motion is nothing but it's an example of curvilinear motion. Tarun, good evening, welcome to the class. We are seeing projectile motion. So projectile motion is nothing but an example of curvilinear motion. So when an object is projected with the initial velocity, it makes an angle with the horizontal. When it does, okay, For example, so this is the point of, yeah, thank you, George. So this is the point, okay, just a moment, this is the point, okay, where there is projection, okay, like this, okay, and it has been done with the initial velocity. This is there is a the object is being projected from this point, okay, with an initial velocity, okay, with the initial velocity u, okay. It makes an angle with the horizontal, this is the horizontal axis, okay. So when an object is projected with initial velocity, okay, it makes an angle, this angle with the horizontal, okay. The motion is neither vertical, we cannot say the object is moving like this. See, when projected, the object will move from here to here. When projected here, it will go like this. So the object is neither vertical nor horizontal. This is also wrong and this is also wrong, okay. The motion of the object cannot be said as vertical, it cannot be also said as horizontal, okay, clear. So that is how, okay. So we cannot say it is said to be in neither vertical nor horizontal. We cannot say it is the object is showing a vertical motion, we cannot say like that, or horizontal motion, we cannot say like that. It is moving inclined to the horizontal, we can say, okay. So the motion of a particle, take down, the motion of a particle is like this. So when the object is projected from here with the initial velocity u, okay, we can say it is at a theta, it makes an angle with the theta, okay. So we can say that the motion cannot be said as, it can neither, the motion of the object is neither vertical nor horizontal, okay. It's neither vertical nor horizontal motion, okay, but inclined, we can say, but inclined to the horizontal. So you know what is inclined to the horizontal, no? Like this, see. So theta, it is inclined, the particle, this is let's say this is the motion of the particle, okay. So the particle is moving like this, okay. So it is inclined, so sorry, it is inclined, I just erased it, sorry. So it is like this, okay. This is a point of projection and it moves like this and it is a velocity, okay. And we can say it's neither vertical nor horizontal but inclined to the horizontal plane, okay. So you're clear with this? Students, are you clear with this? So what happens, so when an object to find the, let's say the, like I said, when an object is moving with the, when an object is projected with an initial velocity u, okay, with an initial velocity u, so it is a point of projection and it comes down here, okay, it comes down here, clear, thank you. And okay, so to find the location of the particle, for example, the particle projected from, let's say this is O, at the point of O the particle is projected, and you can find the location of the particle, like it can be here or here or here, okay. This is P1, P2 and P3, okay. You can find the location or the position of the particle, okay, with respect to the fixed axis, that is x and y reference axis, okay, x and y reference axis. So like this, so when a particle is projected, okay, it with the initial velocity, sorry, okay, with an initial velocity. Okay, sorry. And the position of the particle along the curved, this is a curved path. Okay, this is the curved path. So the position of the particle can be determined. The position of the particle, no, this is p1, p2. Okay, this position can be determined with the fixed axis. This is y and x with the reference axis. Okay, with respect to this reference axis, we can find the position of the particle. We can find the position of the particle being projected. Okay, being projected. Okay, so you understand till now? So these, as I said, these axes are like it are right angles to each other. This is x and y. So these reference axes are at right angles to each other. Okay, hope you understand till now. Yeah, thank you, Joel and Dhanalakshmi, Batma Krishnan, Kandeepan. Yeah, clear. Okay, so that is called as projectile motion. Okay, so you know the mechanism now. So let us define one by one. Okay, so what is a projectile? Okay, projectile can be defined as a particle projected in space. A particle projected in space. Okay, at an angle to the horizontal. Okay, a particle projected in space at an angle to the horizontal plane is called as projectile. Okay, is called as a projectile. Okay, this is called as projectile. Okay, so a particle projected in space like this is the point of projectile. Sorry, this is the point of projection. Okay, the particle is projected in space, it makes an angle with the horizontal. Okay, that is called as projectile. Okay, so angle of projection, that is the angle of projection is nothing but the angle it makes with the horizontal plane. Okay, the angle it makes with the horizontal plane. Okay, when being projected is called as the horizontal. Joel Samraj, from where I have to explain again, please let me know, I'll explain again. Okay, so the angle it makes with the horizontal plane, like see this is the point of projection. Okay, and it makes an angle with the horizontal alpha. Okay, this angle is called as the angle of projection. Understand, the angle it makes with the horizontal plane when it is projected. Okay, when it is projected is called as the angle of projection. Okay, Joel Samraj, from where you want me to explain again, whether projectile or angle of projection, just let me know. Okay, so this is called as angle of projection. Clear? Velocity of projector. Okay, so a particle, you know, in a plane, okay, it is being projected in space. Okay, so when it is projected in space, it will go with the initial velocity. Okay, it will go with the initial velocity. Okay, so that is called as the velocity of the projectile. So it is being projected here. Okay, so this is nothing but velocity. Clear? Very good, Kanishka. Yeah, sure, I'll Joel Samraj, you need to explain, you want me to explain the projectile definition. I'll explain again, just a moment. Okay, so this is called the velocity of projectile. So when a particle is being projected, okay, from horizontal plane, it is being projected with the initial velocity. Okay, it is being projected with the initial velocity. Okay, so that is called as the velocity of the projectile. Okay, so the velocity we can write like the velocity at which the projectile is thrown into space is called as the velocity of projectile. The velocity at which the projectile is thrown into space, okay, it's called as velocity of the projectile. So when you are projecting here, okay, first it will have a initial velocity, let's say u, okay, u is the initial velocity of the projectile motion, the initial velocity of the projectile. So after that it will make an angle with the horizontal plane, okay. So likewise, okay, so this is called as the initial velocity. U is the initial velocity of the projectile. It is measured in meter per second, okay, it is measured in meter per second, okay. So clear till now? Just a moment, I'll just explain what is projectile. Joel Samraj, see, a particle projected in space at an angle to the horizontal plane. Nothing. The mechanism they are saying. See, the projectile definition is this: a particle projected in space like this. This is a horizontal plane. A particle is projected in space. Okay, with an angle to the horizontal plane is called the projectile. So a particle projected in space, see here it is being projected, okay, in space. This is space only, no, in space, okay, making an angle with the horizontal, is called as the projectile, okay, is called as the projectile, clear? So a particle projected in space which makes an angle with the horizontal is nothing but a projectile, okay. That is what the definition is about, okay. Well, Samraj, you're clear, I guess. So Lalita, Raj and Akshya, welcome to the class. We are seeing the basic things about projectile motion, okay. So this is the velocity with which the velocity of the projectile is nothing but the velocity at which the projectile is thrown into space. So when a projectile is projected, it will have a velocity with it, okay. So this is nothing but the velocity of the projectile, okay, and it is measured in meter per second. It is denoted by the letter u, okay, and it can be resolved, no, this u can be resolved, this velocity can be resolved into components. We can resolve the velocity u into components, okay. You can resolve the velocity u with components like this, along, this is O, along OX and along OY plane, okay. It can be resolved into components, that is UX and this is UY, okay, horizontal and vertical components of the velocity of the projectile, okay. So the component of velocity along OX, this one, UX is equal to U cos, sorry, this is the angle it makes, okay, this is alpha, this is the angle it makes, okay. So UX is nothing but U cos alpha. Similarly, component of velocity along OY, okay, is nothing but UY is equal to U sin alpha. You're clear till now what we are doing? So when a projectile is being projected, okay, so when a projectile is being projected, it has an initial velocity, it makes an angle alpha with the horizontal plane. Okay, so what we are doing, we are resolving the velocity into components, that is horizontal component and vertical component. Okay, so the horizontal component, that is component of velocity along ox, is nothing but ux is equal to u cos alpha, and also for velocity along oy, this one is nothing but uy is equal to u sin alpha. You understand till now? Clear? Thank you, Kandeepan. Joel, Samraj, are you clear till now? Lalita, Raj, Akshaya, Kanishka, Ganesan, Sivaparman. So you're clear with this? Yeah. So that is called as velocity of projectiles. First, we are just resolving into components. Okay. The other thing is, you have to this to be noted, the horizontal velocity u cos alpha. Horizontal velocity is nothing but hv, horizontal velocity, is equal to u cos alpha. Okay, vertical velocity is equal to u sin alpha. Okay, u cos alpha and u sin alpha. Okay, so you have to understand this. See, when a projectile is being projected, when a projectile is being projected with the initial velocity, and you have the components, that is u sin alpha and u cos alpha. This is u. Okay, this is alpha. So this horizontal component of velocity, horizontal velocity or horizontal component of velocity, which is equal to u cos alpha, okay, will always be constant. You have to note this down. Okay, u cos alpha, this horizontal component of velocity, when an object is being projected, okay, will always be constant. This value will be constant, and the body is projected, the horizontal velocity value will be constant. This u sin alpha, the vertical velocity component will vary with respect to g. G is nothing but acceleration due to gravity. You get my point? So when a particle is being projected from the, okay, it travels in space, okay, against the g, that is acceleration due to gravity. So the u sin alpha, that is the vertical component of velocity, u sin alpha, the vertical component of velocity u sin alpha will vary because it travels against the acceleration, that is due to gravity. But this u cos alpha, the horizontal component of velocity, will be constant. You understand? You understand till now? So understand till now? Okay, so it will be constant. Okay, thank you, Ganesan. What about others? You are clear? So always this vertical velocity will differ, or it will vary in motion. Okay, in projectile motion this will vary, but this stays constant, that is the horizontal component. This will stay constant and this will vary. Okay, thank you, Kanishka. So I hope everybody has understood. If not, please just give a comment. Okay, so trajectory is nothing but path described by the projectile. Thank you, Batma. Path described by the projectile. So this is the instant of projection O. Okay, from here the projectile is being projected, and this path, this path from here to here, this path is called as the trajectory. Okay, is called as the trajectory. Okay, thank you, Tarun. Batma Krishan, thank you. Joel, thank you. So this path from the instant of projection to the end, from the instant of projection, okay, from the instant of projection to the end. The path described by the projectile is nothing but the trajectory. Okay, so these are some of the definitions. And what about time of flight? Time of flight is nothing but, this is the point where the the projectile, the particle is being projected from here. Okay, from here it goes, and at here it lands again to the horizontal plane. For the starting of the projection, no, from the instant of projection, while the projection has been started, okay, when the projectile has been started from here and ended at here, okay, at the end of projection, okay, or end of projectile motion, you can say, or end of projectile motion. Okay, so the time taken from the instant of projection to the end of the projectile motion is called the time of flight. Okay, we can say like this: total time taken by the particle from the instant of projection to the end of the projectile, okay, end of the projectile, okay, is called time of flight. So when the time starts from here and the projectile ends here, so up to the from that instant of projection, so up to the motion, the time elapsed, okay, is called as the time of flight. Okay, understood? So that is time of flight. Okay, and another one is range. The range is nothing but from the instant of projection here, okay, this is O, from the instant of projection to the end of projection, the distance it traveled, that is from here to here. Okay, this is called as the range. Okay, so it can be defined as the distance between the point of it can be defined as distance between point of projection, that is here, okay, point of projection, okay, and at point which it hits the ground again. Okay, so from here to here, from the projectile started here and ended at here, so what is the distance between the start and the end point? That is called as range. Okay, so clear, everybody is clear? We'll move to the next one. So path of a projectile. Okay, so the path of a projectile, as we have already seen, we'll just construct it. Okay, we'll construct a projectile. Let's say a projectile is being projected, that is from here with an initial velocity u. Okay, from initial velocity u. So the projectile has started here and ended here. Okay, ended here. So this is O. Okay, the start of the projection, that is the end of the projection, is being marked as A. Okay, and let's say this is the highest point. This is the highest point. Okay, highest point, that is the projectile has reached the highest maximum height here. Okay, let's mark it as B. Let's mark it as B. Okay, okay, and as you know, we are going to construct the components. We are going to construct a components, that is the velocity component is u sine alpha, that is the horizontal component is u cos alpha. Okay, so likewise, so we have constructed a projectile. So a projectile is projected with the initial velocity u. Okay, and it has reached the endpoint at A. It has reached the plane at A. Okay, so the projectile reaches the highest point. This is the highest point of the projectile. Highest point of the projectile. Okay, clear. Thank you everybody, thank you. So this is called the highest point of the projectile. Okay, and okay, so let's say P be the, let's say this is This is the point P. This is point P. Okay, this is point P. So this point P is, you know, it is a, you know, portion of the projectile. It is a portion of a projectile after some time t. P is the position of the projectile after some time t. Okay, after some time t. So after a time instant, the position of the projectile is this. Okay, P of x comma y, P of x comma y. Okay, and okay, so it can, like I said in the definition, the path, that is the position of this projectile, this position can be determined by x and y axis, that is the reference axis. Okay, and so the horizontal distance, like this is the vertical distance has traveled. Okay, this is the vertical distance, y is the vertical distance traveled by the particle with respect to this position. Okay, so the horizontal distance traveled is equal to, so what we are going to do, see, first we are observing this, there is a position in the path of the projectile. Okay, now we are going to calculate the horizontal and vertical distances. Okay, so horizontal distance traveled by the particle in any time t. Okay, horizontal distance traveled by the particle, as I said, this will be constant. Okay, that is x is equal to velocity into time taken. Time taken is nothing but t. Okay, time taken is nothing but t. So if you have any doubts, please let me know. Okay, so x is equal to, what is velocity along the horizontal direction? This is u cos alpha. Okay, u cos alpha into t. So x is equal to u cos alpha into t. Now we can do this, take this u cos alpha to the that side, division side, so that is t is equal to u cos alpha by x. You understand? So this is the time instant at the particle here. Okay, this is called as a time instant. Okay, so like I said, this is a portion of the particle on the projectile path. This is nothing but the vertical distance y, this is nothing but the horizontal distance x. Okay, so we have found out what is the horizontal distance, x is equal to u cos alpha t. From this we can find out what is the t, time instant, t is equal to u cos alpha by x. Okay, you understand till now what we have done? Similarly, like for this case, like this. Yeah, sure. See, what we are doing, see, I'm repeating again, just listen. See, what we are doing is, see, this is B, the highest point of the projectile. This is B. This is A. Okay. Now, this is the position of the particle. This is the position P with respect to x comma y. The position of the particle in a projectile. Okay. Batma Krishna explaining again. Please listen. So, what happens here? Like I said, we have seen in the definition, no? Like when like in a path of a projectile, if you want to find a position like this in a path of a projectile like p1, p2, you can do it with x and y. This is x and this is y. Okay, horizontal distance and vertical distance. Okay, with respect to that you can find out the position. Okay, so likewise this is a position of a particle at a time instant at t. Okay, at a particular time the position of the particle is this in projectile. Okay, so what we are going to do, so this is nothing but the horizontal distance x, this is nothing but the vertical distance y. We are calculating for this motion only. Understand? So with respect to this, we have to get the x. Okay, that is the horizontal distance. So horizontal distance is equal to that is x. X is equal to velocity into time taken, velocity into time. Okay, so the velocity here is u cos alpha, horizontal velocity, that is u cos alpha, into time is here, this time instant t. Okay, this time instant t at this particular position at this particular instant. Okay, into t. So x is equal to u cos alpha t. From this, t has been found out as take this u cos alpha here. So t is equal to, time instant is equal to x by u cos alpha. You understand till here? You understand till here, Batma Krishnan, what we have done? So we have found out this value and we have found out this value, t value. Now we are going to find out the horizontal, that is the vertical distance, y value. Okay, so y value can be found out like this. Yeah, thank you, Ganesan. What about Batma Krishnan? Are you clear with this? If not, please let me know. So the vertical distance y is equal to, as you know the formula, that is ut minus half gt squared. Okay, ut minus half gt squared. That is the vertical distance, sorry, vertical distance. Okay, yeah, clear, thank you. So that is called as vertical distance. Okay, so u is nothing but this one, u sine alpha, because it is vertical distance. This is u sine alpha. Substitute it here. Y is equal to u sine alpha into t minus half into g into t squared. Okay, and now you know what is t. What is t? T is nothing but x by u cos alpha, right? X by u cos alpha. So substitute this t value in this equation. Okay, so I'm just taking this to this side, that is y is equal to u sine alpha t minus half into g into t squared. Substitute t is equal to x by u cos alpha. So substitute this in this equation. So when you do that, y is equal to u sine alpha into x by u cos alpha minus 1 by 2 into g into x by u cos alpha the whole squared. So what happens here? This u and u get cancelled. So sine alpha by cos alpha x minus half into g into x squared by u squared cos squared alpha. Just a moment. U squared cos squared alpha. This squared is taken inside. So that is nothing but tan x. This becomes tan x minus half into g into x squared. Okay, g into x squared divided by u squared cos squared alpha is equal to y. Okay, is equal to y. So y is equal to tan x minus half into, okay, minus half into g x squared divided by u squared cos squared alpha. This is called as the, okay, so this equation is of the form, just clear this. Okay, as you can see, this equation is in the form you know, that is y is equal to ax plus bx squared. Okay, it is in the form of y is equal to ax plus bx squared, so which represents a parabola. So the path traveled by the object between that that motion, no, it represents a parabola. The path traveled by the projectile, it represents a parabola. Okay, and this equation y is equal to tan x minus half g x squared by u squared by into cos squared alpha is called as equation of trajectory. Okay, equation of trajectory. So this is called as the equation of trajectory. So when there is a projectile motion, and if you want to find out the trajectory, you can use this. Let's say there is a problem with projectile motion. They are asking what is the equation of trajectory, or the path, or what is the path of the projectile. If they ask, you can apply this formula: y is equal to tan x minus half into gx squared divided by u squared cos squared alpha. Okay, you can use this formula. You can find out the equation of trajectory or the path of projectile. You understand till now? You're clear with this? So what is this equation is called as equation of trajectory. Okay, I just worked it out how it came. Okay, how this formula has come into existence, I have just explained to you, so that you will not forget it. That is, y is equal to tan x minus half into gx squared by u squared cos squared alpha. Never forget it. Okay, thank you, George, Kanishka, Joel, Samraj. Are you clear? So is everybody clear? Okay, so we'll move to the next one. There are some standard results, like standard results in terms of yeah, like this one. See, no, I'll just go to this one. Okay, standard results can be obtained from these equations. There are standard results can be obtained. That is, one is time of flight. So time of flight is nothing but in the last diagram we have seen, no, from the instant of projection. Okay, so this is O and this is A. This is the highest point. Okay, highest point B. Okay, so we can say this OB, no, this OB is the upward motion of the projectile. Upward motion of the projectile. Similarly, BA is nothing but downward motion of the projectile. Okay, so OB is the upward I'm just referring to this diagram. Okay, so here OB is called as the upward motion of the projectile, and BA is nothing but the downward motion of the projectile. So let's calculate this. See, let's calculate the upward motion of the projectile, OB. So from O to B, you can apply this formula, that is V is equal to U minus GT, right? V is equal to U minus GT. So at B, what happens at highest point? It should be noted, highest point, the velocity of the particle is 0. Okay, what happens in motion under gravity? So when you throw a ball or something, an object upwards, okay, upwards, it reaches the top, okay, and it reaches maximum height, h max, and the velocity at this height, the maximum height, becomes 0. Likewise, in projectile, the ball with the initial velocity u, here this u becomes 0. Okay, afterwards it it speeds up. Okay, the velocity becomes increasingly, okay, at the end point. So likewise, okay, so after attaining 0 here, it will increase. Okay, it will increase, okay, in the downward motion. So at highest point the velocity of the particle is 0. Substitute that in this. So we are doing ob operation. So v is 0 is equal to u minus gt. Okay, so that becomes what? U is equal to gt. Okay, u is equal to gt, and we have to apply this one also. See here, no, this ob, this in upward motion you have to use this one vertical, no, vertical component, that is u sine alpha minus gt is equal to v. Okay, v becomes 0 is equal to u sine alpha minus gt. So what happens? Take this u sine alpha here. So u sine alpha minus is equal to minus gt. Minus minus will get cancelled, and u sine alpha by g is equal to t. Understand? So time taken is equal to, that is from O to B, time taken from O to B is equal to t is equal to u sine alpha by g. Okay, time taken for the projectile to reach from O to B, time taken by the projectile to reach from O to B is t is equal to u sine alpha into g. Okay, here also the same thing, time of ascent is equal to time of descent, like this. Okay, so this is P A and this is O. OB, the time taken to reach OB is equal to PA. Okay, so the time of the total time taken is time of flight, right, from the instant of projection to the end point. Okay, so that is, we can say time of flight is equal to 2 into time taken by the object to reach OB. So 2 into, like I said, u sine alpha by g, it's nothing but 2u sine alpha by g is equal to t, capital T, time of flight. You understand till now? Are you guys clear till now? The same thing, see, time of flight is equal to t is equal to 2u sine alpha by g. You understand till now? Clear? So what is time of flight formula? Time of flight t is equal to 2u sine alpha by g. Thank you, Kanishka. Padma Krishnan, thank you. What about Joel Samraj? So you guys clear with this? Time of flight t is equal to 2u sine alpha by g. Okay, so another one is maximum height attained, that is h max, we can say h max. Maximum height is h max. Understood? Thank you, George Vincent, thank you. So that is h max, maximum height attained. Okay, as you all know, B is the maximum height attained by the projectile O and A. Okay, so we can say this is the maximum height attained by, this is nothing but the h max, maximum height attained by the projectile. Okay, so as we know, the highest point, at highest point velocity is equal to 0. Okay, so I can use this relation, h is equal to ut minus half gt squared. So here h is equal to h max, maximum height. Okay, u here is u sine alpha, okay, because vertical motion we are considering, so u is equal to vertical component of velocity, that is u sine alpha. So substitute it here. Okay, that is u, and you know what is t, no? T you have already found out. T is equal to u sine alpha by g. Here we have found out what is t here. Okay, t is equal to u sine alpha. So substitute this in the equation. Okay, so that becomes u is u sine alpha. Here t is u sine alpha by g minus half into g into t squared is u sine alpha by g the whole square. So this becomes u squared sine squared alpha by g. Okay, and minus half into g into u squared sine squared alpha by g squared, taking this squared inside. So this g and this g get cancelled. So what happens here? I'll write it here. So it's nothing but h max is equal to u squared sine squared alpha by g. Okay, sine squared alpha by g. Okay, so into that g is cancelled, so that is here g is cancelled, so that is minus half into half into u sine alpha. Okay, u squared sine squared alpha. Clear? U squared sine squared alpha by g. Sorry, there is a g should be there, so by g. Okay, so what happens here? So this is half u squared sine squared alpha. This is 1 u squared sine squared alpha. So when you minus this, what happens? Plus half u squared sine squared alpha by g, which is nothing but u squared sine squared alpha by 2g is equal to h max. H max we can say, or maximum height we can say, is equal to u squared sine squared alpha by 2g. Clear? Clear till now? So what is maximum height? Okay, so let's say the other thing, horizontal range. Horizontal range is nothing but, in the same diagram we can say, just like this. This is a point of projection O, and this is A. This is called as the horizontal range from O to A. Okay, the same thing, what we'll do to find out the distance OA. Distance OA is horizontal range. Distance OA is horizontal range. So OA is distance is equal to component of velocity, component of, or we can say horizontal velocity, h velocity, okay, into time taken from O to A, time taken from O to A. What is horizontal velocity? That is u cos alpha into time taken from this thing, O to A, that is the time of flight. What is time of flight? So this one, substitute it here. So is equal to 2u sine alpha by g. Okay, 2u sine alpha by g. We can write it like this. So this becomes u squared 2 sine alpha cos alpha by g. We can say sine 2 alpha is equal to 2 sine alpha cos alpha, that is sine 2a formula. Sine 2a is equal to sine 2 sine a cos a, so that we can apply here. Okay, so when you apply that here, it becomes u squared sine 2 alpha by g is equal to horizontal range, is equal to range. Clear? So this is called as range. Okay, maximum horizontal range is there. Okay, maximum horizontal range is there. So when you know what is range formula, that is this one, u squared into sine 2 alpha by g. So when the range will be maximum, when this becomes maximum, range will become maximum. Okay, so this thing r will be maximum when this component as this range will be maximum when sine 2 alpha is maximum. When sine 2 alpha is equal to maximum value, range will have a maximum value. Okay, So in order to make sine 2 alpha is equal to maximum, it is equal to when sine 2 alpha is equal to maximum, when sine 2 alpha is maximum, when it is equal to 1. Sine 2 alpha is equal to 1. So here what happens, so take this sine this side, so 2 alpha is equal to sine inverse of 1. Sine inverse of 1 is 90 degree, so 2 alpha is equal to 90 degree, and alpha is equal to 90 degree by 2, and alpha is equal to 45 degree. So when angle alpha is equal to this thing, so when the angle, okay, is equal to 45 degree, we have maximum horizontal range. Clear? For example, when a projectile, see, when a projectile is projected here, okay, like this, with 45 degree, it will have a maximum horizontal range. If it is O, then A will be here when it is 45 degree. For example, if it is 60 degree, okay, if it is 60 degree, then A will become here. It will be less than the horizontal range that is being projected at 45 degrees. So when a projectile, when you throw a ball here with respect from here with respect to the 45 degree, in 45 degrees if you throw, it will cover a larger distance. Okay, so when theta, that is this angle theta, is equal to 45 degree, or alpha is equal to 45 degree, it will have a maximum horizontal range, that is maximum horizontal distance. From here it will cover a larger horizontal distance. Okay, so that's why you have seen, no, in rocket launching like this, see, they have done it in 45 degrees. They have done it in 45 degrees. So when you launch a missile here, so it will travel a longer distance and reach the enemy. Okay, it will have a longer distance, it will cover a longer distance and it will reach the enemy. So when the angle is 45 degree, the projectile, this missile, no, this missile projected will reach the enemy who is at a larger distance, that who is at a very high distance, no. So that can be also done. See here, that's why it is projected with 45 degree only. 45 degree only. The missiles are being projected at 45 degree, so that it will reach the enemy who is far away. Okay, so it will reach the enemy who is far away. Okay, clear? So when this angle theta is equal to 45 degree, range is equal to maximum. Clear? Clear with this? So clear with this, students? Actually we have NCERT questions, some of the NEET questions also to be solved. We'll continue that in the next class. Okay, we'll continue that in the next class. We have completed the concepts. If you have any doubts, please let me know. So do not forget the formulas. Okay, whatever the formulas we have seen, you should not forget it, because you should have it in your mind so that you can solve some of the NEET JE and also some NCERT questions. Okay, so we'll see in the next class. Okay, we'll see in the next class. We'll discuss some of the problems, NCERT problems, and also some of the NEET and JE questions also. Okay, so you're clear with this? So in the next class we'll see. Okay, thank you students. Thank you Batma Krishnan, Ganesan, and Kanishka, George, Stefanio, and Ganesan, Kandeepan. Thank you George. So we'll see in the next class. Okay, thank you for the sticker, Stefanio. Thank you, Kanishka. Thank you. So we'll meet in the next class. If you have any doubts, please let me know. Amit, welcome to the class. I think we are at the end, but no problem. Welcome to the class. This video will always be there. You can watch it anytime you want. Joel Samraj, I hope you're clear. Okay. If you have any doubts, please post it. So I think there's no doubts, I guess. So thank you. We'll meet in the next class.